Hello everyone, myself Mrs. Archana Mhatre, lecturer in Electronics and Telecommunication Department. In this video, we are going to start with the third unit of microcontroller and application, that is 8051 timers, interrupts, serial and parallel communication. So let's start with the timers and counters. 8051 has two 16-bit timers or counters, that is timer 0 and timer 1. Their main purpose is to measure time and count external events. They can be controlled, set, read and configured individually. They can be used for generating clock pulses in serial communication. They can be used as a timer to generate time delay or as a counter to count the external events outside the microcontroller. Both the timers, that is timer 0 and timer 1, are of 16-bit. Each counter may be programmed to count internal clock pulses when it is acting as a timer and to count external clock pulses when it is acting as a counter. Now there are resistors in timers. 8051 microcontroller is a 8-bit architecture. So each 16-bit timer is accessed as two separate resistors, low byte and high byte. Timer 0 register is accessed as TH0 8-bit and TL0 8-bit. Timer 1 register is accessed as TH1 8-bit and TL1 8-bit. When the timer is properly loaded with the value returned to the timer register, then the value will be incremented or decremented once per each machine cycle. 8051 has timer mode T-mod register and timer control T-con register for selecting a mode operation and controlling purpose. So there are two timers, timer 0 and timer 1, and register of timer 0 is TH0, TL0, register of timer 1 is TH1, TL1. Now this is the timer register TL0 and TH0 for timer 0, and this is for timer 1 TL1 register of 8-bit and TH1 register of higher 8-bit. Now next, T-mod. It is a special function register, timer mode register. T-mod is a 8-bit register used to set timer mode of timer 0 and timer 1. The timer mode T-mod SFR is used to configure or change the operating modes of timers in 8051. So to select a particular mode in a timer, there are 4 modes of timer, mode 0, 1, 2 and 3. So to select a particular mode, the T-mode register is used. Now lower order bits refer to timer 0 and higher order bits refer to timer 1. So this lower order bits is for timer 0 and the higher order bits are for timer 1. Now if you can see here, the bits are same for timer 0 and timer 1, that is for timer 0, gate 0, C/T0 bar, M1, M0. For timer 1, same bit, gate 1, C/T1 bar, M1 and M0. So this is the format of the T-mode register. Now first gate bit for timer 1, it controls run or stop of the timer. If it is 1, then start the timer. Set TR1 bit. TR1 bit is in T-con register. When INT 0, INT 1 bar high. INT 1 bar, that means external interrupt 1 high. Now if gate bit is 0, then start the timer, set the TR1 bit in T-con register, and it will not consider the status of external interrupt 1 bar. Now next is the C/T1 bar bit. C/T1 bar, that means count timer or counter. If it is 1, if this bit is 1, then it will act as a counter. If this bit is 0, then it will act as a timer. Now next is a mode selection bit, M1, M0. M1, M0, it is used to select a particular mode. As I have told you that timer has a 3 mode. mode 0, mode 1, mode 2 and mode 3. If the combination is 0, 0, then mode 0 is selected. Combination is 0, 1, then mode 1 is selected. If the combination is 1, 0, mode 2 will be selected, and if the combination is 1, 1, then mode 3 will be selected. Now this is the description of a particular mode. Mode 0 is a 13-bit timer, mode 1 is a 16-bit timer, mode 2 is a 8-bit auto reload mode, and mode 3 is a split mode. Now next, for timer 0, gate 0, description is same as gate 1. It will run or stop the timer. If it is set, then start the timer, set the TR 0 bit in TCON register and consider the status of external interrupt. If it is 0, then start the timer, set TR 0 bit in TCON register without considering the status of external interrupt int 0 bar. Now next, C/T0 bar. If it is 1, act as a counter. If it is 0, act as a timer. Then M1, M0, same for mode selection bit. Now next is a TCON SFR, that is timer control register. The timer control, that is TCON, is a register whose bits directly control timer operations. TCON is an 8-bit control register and contains a timer and interrupt flag. Only 4 of all 8 bits in this register are used for timer control, while remaining 4 are used for interrupt control. That means TCON is a 8-bit register, and out of 8 bits, 4 bits are used for controlling the timer and remaining 4 bits are used for controlling the interrupt. Now this is the status format of the TCON register. Bit 0 to bit 7. Bit 0 is for IT0, IE0, IT1, IE1. This for interrupts. These 4 bits are for interrupt control, and these 4 bits for timer control. That is TF1, TR1, TF0, TR0. These 4 bits are for timer control. Now we will see the explanation of this TCON register. First, TF1 and TF0 bit. The full form of TF is timer overflow flag. This bit automatically set when the timer gets overflow, means it changes from FFFF to 0000H. FF, that means it will changes from highest value to the lowest value. That means when it is overflow, this bit is set. It can be set through the software. Now next bit is TR1, TR0. TR1 is a timer run control bit. If it is 1, then timer is turned on, and if it is 0, then timer is turned off. Next, for interrupt, IE0 and IE1. This is the external interrupt flag. This bit indicates whether external interrupt is activated or not. In edge trigger mode, set at falling edge of a signal. In level trigger mode, set at the low level signal. Next bits are IT0 and IT1, that is external interrupt type. This bit indicates triggering type of the external interrupt. If it is 1, then the type is edge trigger mode. If it is 0, then the type is level triggered mode. So these 4 bits are for interrupt control. Now this is the same explanation of the TCON register. Thank you.